Hello, everyone, and welcome to day 54 of the 100 Days Programming Challenge. And today is day 4 of our Christmas special tutorial. And today I'm going to do something special just for you. As you know, in most parts of the world, it is currently snowing, but don't worry if it is not snowing where you are. I'm going to make it snow in Python just for you. So today we will be creating a snow animation in Python. Happy Christmas Eve. I said I will be making it snow for you, just for you in Python using Pygame. So what do I want to do? I want to create falling snowflakes that will drift down the screen, and it will have a random starting position. It should have different speed and sizes to create a more natural snow effect. So I will be using Pygame. If you're a regular on this channel, you know now I'm a fan of Pygame. I use Pygame for almost everything now. The first thing that I will be doing is to import our packages. So I'll be using the Pygame and random. Pygame is used for creating games and graphical application, while random I would use that to generate my random position, my random speeds and sizes for my snowflakes. So the first next thing I'll do is to initialize Pygame, and how you do that is Pygame dot init, and like that I've initialized Pygame. I want it to be displayed on the screen, so I want to create like an interface where you'll be able to see my snowflakes. We won't be using Tkinter, so if you want to avoid us from use Tkinter all the time, nope, not using Tkinter today. So then I have to specify the width of my screen and also like the caption, the title of my screen. So you can use whatever width and height that you want. First, let's try it with this width, and then we'll see if we have to make it bigger or if it is perfect the way it is. So my width is 800 and my height is 600. And to display your screen, you have to use the pygame dot display dot set mode, the width and the height. And this is my set caption, snow animation. So now let's create our snowflakes class. So if you want to learn about classes, we discussed about that recently. So you should check the video on object-oriented programming. So we have our class, which is snowflakes, and during the object-oriented programming class, that we have to create our init function. And in our init function, we would set the random starting position, the random speed, and then the random size. So let me show you how to do that by using the init function. Want my start, you see my x and y axis, they are from a random starting position in the width and then the height, and then my sizes I want them to be random from 2 to 5, and then the speed I want it uniform from 1 to 3. So because I don't want the snowflakes to be the same, because snowflakes, they don't fall like on a straight vertical line and just in the same direction, and so I also want to give it like a natural feel. That's why I'm using this. Next, I want to do the fall and the reset. So when it reaches the bottom of my screen, I want it to reset and then fall again. So I would have another function for that. That would be dev for self. Then I would have my self dot y plus or equal to self dot speed. And this function here, the self dot y plus or equal to self dot speed, it's going to update the snowflake's vertical position based on its speed. So it's updating the position, and this is going to like stimulate the fall. So updates position based on the speed, so it stimulates the fall of it. And then I want to have an if condition that if the snowflakes moves below the screen, it is to reset to a random position above the screen with a new speed and a new size. So as I said, that we're trying to mimic the fall. So when it gets to the bottom, I want it to reset. So these are my two functions. The self.x here, random horizontal starting position, self.y, random vertical starting position, self.size, the random snowflake size. I'm using a small size because I want it to have like a natural look. And self.speed is random size for variability. And then the falling behavior, that is my dev fall. I wanted to update this updates the snow vertical position based on the speed to stimulate falling. While this that if the snowflakes move below the screen, it has to reset to a random position above the screen with a new space and a new speed and a new size. Okay, so now let's draw our snowflakes. We have to draw our snowflakes. So want to draw a white circle representing the snowflakes on the screen at the position X and Y and with the radius of our random radius size that we set there. So that's what we want to do. So it is a white circle that we're drawing. So we'll use the pygame dot draw circle and then we'll specify the position on the X and Y axis and then the size. Remember, position of X and Y axis are random. We already called it here as random. So this is our third function. So we're using the pygame draw circle. And next, let's create our snowflakes. Here we would have to specify how many snowflakes that we want to create. So I would have the number of my snowflakes. Let me make it 200. And if it's not enough, and then we can increase it. And then this specifies the number of the snowflakes. And then I want to create a list of a snowflakes object. And I'll be using list comprehension. Remember, we talked about list comprehension on Friday. So I want to create a list of the snowflakes object. If you're following, we've created a random static position, random speed, random size, and then the random fall. And then we've drawn our snowflakes. Here we're defining how many snowflakes we want, and we're creating a list for the numbers of snowflakes. So the next thing that I want to do is to initialize a loop control. I want to keep the loop running until an event like closing the window would stop it. And then I want to also create like a clock object that manages the frame rate of the game. So it ensures that the loop would run at a constant speed. So in this case, I will be using 30 frames per second in this case. So let's have our running that it should continue to run until there is an event that stops it from running. So my running is true. And then let's create a clock object. So I have clock equals to pygame dot time dot clock. So we've had that in place. And next is thing that I want to do is that while the loop is running, I want to put like a background color because I want it to like imitate the night sky color. So I've used my screen dot fill to set the color. You can also add music. So if you want while you're working on this code, you can add like a Christmas carols, just kind of like set the mode. To learn about how to add carols, you can watch yesterday's video. That was what we did. So this will fill the entire screen with a dark blue color resembling the night sky. And then what else do I want to do? I want to retrieve all the events, all the key presses or the mouse click that occurred since the last iteration. And then if the event type, that is if the user closed the window, then I want it to end. So this is, it will run continuously like I said previously. But then how do you know when the user has closed the window? That's when we would use the for loop. That so if the user should close the window, then it means that it has ended and then the whole thing to quit. So by doing the events dot get, by getting all the events that occurs, all the key presses, all the mouse clicks. This is kind of fun to like know what happens to be able to get at the point where the window is closed so the program knows that it should quit. So for all the events in pygame event.get, if the event.type, that is, if pygame is quit, like we open the interface and we close it, then the running that we set to true here, that it will continue to run, we then set it to false. And then let's update and draw our snowflakes. Now let's call our function our fall and our draw. So for snowflakes, in snowflakes, we're calling our fall and our draw. So we're initializing the process that, oh, we want it to fall and we also want to draw it to the screen. So we've called our function. And then finally, we want to update the screen with all our changes during this iteration. How do you do that, you might ask? You would use the pygame.display.flip to update it. And then we will then set what our frame rate is. Remember, we use clock here. We have to specify what our frame rate is. And we're using 30 frame rate per second. We have to exit the pygame. So once this running is set to false, the program would exit the loop and it will call the pygame.quit. And there we have it. This is our pygame. So the loop will run continuously while running is true. And what happens in each iteration? It clears the screen with a background color. It handles the user's events, that is the closing of the window, and it updates the position of each snowflake, by using the for function, and then it withdraws all the snows to the screen, and it updates the screen with a new frame and waits enough time to maintain the 30 frames per second. And when the user closes the window, the running is then set to false and the loop exits and the pygame quits. So now let me run this. This is our snow animation. You can see that it's of different sizes. That's because we set the size to random. And you see it's falling at different positions because the position of our X and Y is also at random. And the speed, you can see the speed at which it's falling is also at random. That's because we set everything at random. And you see that when it falls, it gets redrawn back to the top and then it keeps falling again, and it will continue to fall until you close the program and then it ends. So you can increase the number of snowflakes that you want to, and also the size of the screen. If I choose to make this like 1,000 and then this 800, and then if I run this, see now we have more snowflakes. This is nice. So I have made it node for you. You're welcome. So these are things you can practice. You can change the number of the snowflakes. You can change the background color. You can change the speed and the size and whatever you want it to do. So this is our day 4 of the Python Christmas special. Let me know if you'll try it. And I'll see you tomorrow for Christmas Day. Thank you very much for watching our Python Christmas special. As usual, the link to the Jupyter Notebook is in the description. Feel free to check it out and play around with it. And again, I wish you a Merry Christmas in advance. See you tomorrow.